so for solving this, we use a formula called L is equal to n minus 1. Is that right? So whereas the L is the azimuthal quantum number, the L is the azimuthal quantum number, and the n is the principal quantum number, right? The L is the principal quantum number. All right, so let's solve first question. So the first question says that determine the value for the K shell. Determine the azimuthal quantum number for the value of the K shell. All right, so so our question says that determine the azimuthal quantum number for the value of the K shell. Now I told you that when you have the K shell, it means the principal quantum number. And what's the value of the K shell here? Is what? It's 1, right? It's 1. Now our azimuthal quantum number is what? It's L. We don't know, right? So we put it in the formula. And the formula says that L is equal to n minus 1. Is that right? Then our L is equal to, our n is what? Our n is 1. So 1 minus 1, right? So 1 minus 1 will give you 0, right? So our L is equal to 0. If you can even solve it without using the formula. So if you look at it, when n is equal to 1, our L is equal to what? 0, right? If L is equal to 2, our L is equal to what? 1. Is that clear? All right, so solve this question and leave it at the comment section. All right, so you are going to determine the azimuthal quantum number for the value of the n shell. So you solve it and you leave your answer at the comment section. All right, so let's move on to another quantum number. All right, so we are moving on to another type of quantum number, that is magnetic quantum number. Now, what does it describe? 1. Magnetic quantum number describe the subshells in the orbitals. Is that right? It describes the subshells in the orbitals. All right, so it is ranges from negative L to plus L. This must be noted. Magnetic quantum number ranges from negative L to plus L. Is that right? All right, so let's take example so that you can get an understanding. So let's take an example. So determine the value. So our question says that determine the value of ml, right? The value of ml when L is equal to 2. Is that right? So our L is equal to 2, right? And I told you that the ml is ranges from negative L to plus L, right? So if you're having your plus 2 here, so negative 2 plus 2. Is that clear? All right, so our ml is equal to, so you are starting from the negative 2 to plus 2. So negative 2, you move to negative what? 1, right? 0, then you go to 1, you go to 2, right? You go to plus 2. All right, so our ml is equal to negative 2, negative 1, 0, 1, and 2. Is that right? So you to solve this question. So determine the value of L when L is equal to 3. Solve it and leave it at the comment section. Is that right? All right, so this is our spin quantum number. That is the last quantum number. Now, what does it describe? It describes the direction of the electrons, either clockwise or anti-clockwise. Is that right? So it describes the direction of the electrons, either clockwise or anti-clockwise. All right, so it is written here as 1/2. Sorry. So let's say this is our s orbital. This is our s orbital, right? And this is our electrons. So one go up and one comes down, right? So we have negative 1/2 or plus 1/2. Is that right? So this is what it describes. It describes the direction of the electrons, right? Either clockwise or anti-clockwise. So let's solve questions That's so that we can get the understanding of it very, very well. All right. So write out the values for the four quantum numbers for the following numbers, right? So for the four quantum numbers, we're having n as the principal quantum number, right? We're having L as the azimuthal quantum number. Then we're having our spin, right? And then our ML, that's the magnetic quantum number. Is that right? So for the 3D, what is our n here? Our n here is the 3. Is that right? Our n is equal to 3, right? Now, what is our L here? Now, our L is the d orbital. Is that right? So if n is equal to 3, our L will be what? 2. Is that right? So when you put it in the formula, I told you that we have a formula that's n L is equal to n minus 1, right? Then our n is what? Is 3. So L is equal to n minus, so our n is 3, so 3 minus 1, our L is equal to 2. Is that right? Now, what is our magnetic quantum number here? For you to know the magnetic quantum number, first you have to get the azimuthal quantum number. So our azimuthal quantum number here is L is equal to 2, right? So we are going to use our L is equal to 2 to solve the magnetic quantum number. All right, so we're having plus 2, right? And I told you that the magnetic quantum number ranges from negative L2 plus L, right? So we're having our positive 2 here. So positive 2, 2 plus 2. All right, so we're having negative 2. We go to negative 1, 0, right? 1 and 2. Is that right? So our ML is equal to negative 2, negative 1, 0, 1 and plus 2. All right, so this is our ML. Now let's go to our spin quantum number. Our spin here is equal to 1 over 2 or negative 1 over 2. It doesn't change. Is that right? So you to solve this one and leave it the answer at the comment section. So let me take the 4s. Let me solve last one 4s so that I can solve the rest. So our n here 4s. Our n here is what? The 4. Our n is 4. All right. Now in the s orbital, yeah, our s here is what? Our s is 0. So I told you that we have L, so we have the S, P, D, and what? F, right? So our S is what? 0, 1, 2, 3, right? 4 and 5 here. Is that right? So our S orbital L is equal to what? 0 here. So our L is equal to 0. Now, if our L is equal to 0, our ML will also equal to what? 0, because we cannot see negative 0, positive 0. No, it's ML is equal to what? 0. Our spin is equal to plus 2 or negative 1 over 2. So if you find it helpful, make sure you subscribe and also share to your friend as well. Thank you.